Welcome, students. Today we are going to learn about a special sequence, right? So this sequence, how is it special? And we call it AP, right? So we are going to learn about what is AP and why do we call it AP and what actually AP stands for. And then after learning the concepts, what we are going to do is we are going to solve a really basic question, right? So let's do it. I'm sharing my screen with you, so you'll be able to see what we're gonna do. Okay, before I start, I have a question for you. You can see two sequence in front of you, right? We call them sequence because they have many um, many numbers which are arranged in different sequences, right? So here you go. Do you see in the first sequence, if I subtract the second digit from the first one, what do I get, right? What do I get? Here I'm getting a 0. If I subtract this, what am I getting? I'm getting a 1. If I subtract this, I'm getting a 1 again. Am I? If I subtract this, I'm getting a 2. If I getting subtract 5, I'm getting a 3. If I subtract 8, I'm getting a 5, right? 8, 13, and so on, right? Do you notice something here? Yes, if you notice, that's really great. So here, if you had noticed, what is behind 1? There's nothing. So 0 is added. What is behind 1? It's 1. So 1 is added. What's behind 2 is again 1. So 1 is added. What's behind 3? It's 2. So 2 is added, right? What's behind 5? It's 3. So it's 3 is added, right? So this is one kind of sequence, right? In a similar fashion, it is moving on. Okay, now let's consider the second sequence. It is, all right, what is added here? All right, it's 2. Okay. Here, again 2, again 2, again 2, and again 2, and so on, right? Now the first sequence that you just noticed is called a Fibonacci series, right? Or a Fibonacci sequence, right? The sequence that you are seeing under it. What's the difference between this sequence and this sequence? The difference is that here, the number which is added to the previous number is the same, right? Is the same. So such sequence, right? Where the same number, right, is added or subtracted, right? Any one of these operations is performed. Either the same number is added, or maybe it's another case, the same number is subtracted. So such a series is called AP. What is it called? AP, and AP stands for arithmetic progression. Okay. So we call it arithmetic progression because there is an arithmetic operation that we are performing, right? What is the arithmetic progression? Arithmetic operation, we are adding 2. Again, we're adding 2. Again, we're adding 2, right? And it's a progression. See, it is progressing, right? We are getting a series, okay? In this case, the 3 dots over here, if you can see, it represents that the series or the sequence can go infinite. It can go up to infinite, right? We can also write it like this with the help of this sign, right? So you can write any numbers. That's why it can go infinite. Or it can be finite. For example, say this. So I have got 1,000 rupees in my piggy bank right here. And like I am taking out 200 rupees every month, right? So in the next month, in the first month, when I am taking 200 rupees, right? How much am I left with? I'm left with 800, right? And in the second month, if I'm taking 200 again, how much am I left with? I'm left with 600, right? And so on, right? In the fourth month, right? How much am I left with if I do it like this? Any guesses? Am I going to be left with 200? Right? And so after this fourth month, when I again take out 200 rupees, right? In the fifth month, now my balance is zero. I cannot take any more money out. So you see here, such a series which started from 1,000 and 800, 600 to zero. Now in this case, in the case of money, it becomes a finite series, right? So a series, for example, it has one, two, three, four, five terms, right? Now there is something which I just said. I said term. Let's understand what is a term. And what are the things we are going to do? This is a question that we are going to solve, but first let's understand the concept. So in an arithmetic progression, like we just saw, we had a series, right? 2, 4, 6, 8, 10, 12, and so on, right? So there are some terms that we need to understand. First term, right? And then we have a common difference. And this first term we denoted by the letter A, right? And the common difference we denoted by the letter D, right? And the next term that we use is N. N is basically the number of terms in the sequence. And also, you'll also see the notation like AN, which we call the last term, right? But before that, let's understand what is a term, right? So what is a term? You see here, every number in the sequence is called a term. It is called a term, right? So let me suppose, as you see, each number we have a plus 2 over here, right? Number that is preceding, we have to add a 2 to that number to get the next number, right? And this is repeating, right? This is repeated in the sequence, right? So the number which is repeated, continuously repeated, we call it the common difference. For example, in this case, D is 2. A is called the first term. And if you can see, so this first term in this sequence is 2. So the first term in this sequence is 2. N is the number of terms, and because we are not sure this series goes up to infinity, so we are not sure of the number of terms. So they're infinite, right? And an is the last term. So what basically do they mean? Okay, let's understand. For example, I have a general arithmetic progression. The first term is a, right? And then I have got, or maybe it's 0, and then I have a 1, then I have 2, and then I have 3, right? Or maybe I would just not take a0 and we'll start the progression with a1. Okay. Yeah. A1, A2, A3, A4, and so on, right? And consider this to be an finite series. So it has a last term. There are finite number of terms. They are not infinite number of terms. So there are finite number of terms over here. And we know that the first term, I have taken it as A, right? And there is a common difference, that is a same number which is added or subtracted to it. So in this case, I'm taking it as like adding it. Okay. So same number is added to get the another term. So can I write it like this, that this number A1 is A, so I can write A2 as A plus D, right? Similarly, I can write A3 as A2 plus D. And A2 is A plus D. So I'll be getting A plus D for A2. This over here, A plus D. And I'm adding another D again. And this will amount to A plus 2D, right? Okay, fantastic. So same operation I can do with A4, right? So what is A4? It's nothing but A3 plus D, and A3 is A plus 2D. So here I'm putting the value of A3, right? So what am I getting? I'm getting A plus 3D. And now you need to see the pattern that we are having. So in this one, if you see, what is the pattern that we are having? So I can write this as A I can write this as A plus 1 minus 1D, right? And I can write this as A plus 2 minus 1D, right? And I can write this as A plus 3 minus 1D. And I can write this as A plus 4 minus 1D. Now you would ask me, sir, why are you doing this? And why are you even showing this to me? Okay, I'm showing you this because there is a pattern. When I was looking for A1, so I'm subtracting 1 minus 1, right? When I'm looking at A2, I'm subtracting 2 minus 1 times D. Or maybe I'm just adding 2 minus 1 times D to A. When it's A3, so I'm basically adding 3 minus 1 times D to A. Okay. Why I'm doing this? I'm doing this to get a general expression for AN, which is our last term, right? Because we didn't know this last term. Now, what is this N? See, there are N number of terms. N can be any number. It could be 10, it could be 100, it could be 1,000, right? It could be any number of terms. So here, what are we getting is AN. So like all of the terms, I can write it at A plus, and like here it's 4. So here, instead of 4, we have N. So I'll replace this by N minus 1 into D. So this is how actually we get a formula. And this formula is this for the last term of the AP, right? And do you also notice that the common difference is the same? And how do we find the common difference? I can subtract any term from its previous term, right? I can subtract any term from its previous term, and I will always get common difference, right? This is how simple it is, right? So this is something that you should remember. And now because you have already understood it, I'm sure you'll be able to remember it. And this is also a really wonderful concept because this is the concept on which arithmetic progression is based. So now let's go to the problem that we have written. Okay, and try to solve it. You can saw the problem on my screen, right? So here we have an AP, and AP is 21, 18, right, 15, and so on. So it's an infinite series. And we need to find which term is going to be minus 81. So if you see, if you note, there is a term which is subtracted from it. And in this case, it is 3, right? Okay, so I know now the first term is 21. So A is 21, right? And because 3 is subtracted, so my common difference, which is D, is minus 3. And because I need to find this term, and I don't know which term is this, so I need to find N because I don't know which term is this. So I need to find N. And I am given that this term is nothing but minus 81. And I know I just calculated the formula for AN, which is AN is equals to A plus N minus 1 into D. Here I got AN, I've got A, I've got D. Voila. So here I've got this. I only need to find one variable, and this is possible. If I have all the three variables, I can easily find n. So let me put all the values and see what am I getting. Putting an is equals to minus 81, right? And then instead of a, putting 21 plus, keep n minus 1 as it is and multiplying it by minus 3. So whenever there is another sign like minus in this case, so we have to put a bracket, okay? So that we are able to know there is a minus sign, okay? If we don't put a minus sign, so it will become an arithmetic progression, like it will look like it's subtracted from this one, okay? We don't want to make that mistake. So how are we going to solve this? So let's bring this 21 over here. So we'll get minus 81 minus 21, right? And now let's multiply minus 3. So we are left with n minus 1 into minus 3 over here. Okay. Minus minus is plus. We get a minus sign, but we need to add these. Okay. So we are getting 102. We need to multiply minus 3 into this. So we'll be getting minus 3n, and minus into minus get a plus. So we get a plus 3, right? Now, this 3, or what we can do is take this minus 3n to the left-hand side. So we get a plus 3n. And now here 3 is left, and we bring this minus to either, we'll get a plus 102, right? So it is 3n is equals to 105, and n equals to 105 over 3, which is 35. So now, what does this show? This shows that at n is equals to 35. That means the 35th term of this sequence is minus 81, hence solved, right? So I hope you understood the concept of arithmetic progression and you are able to solve some of the basic questions like this one that we just solved, okay? So thank you for watching and I will see you in the next video, okay? Thank you.